Okay, question 18. The line 3x plus 2y equals c intersects the x-axis at P and the y-axis at Q. And if the area of the triangle OPQ is 24, find the value of c. Okay, so the first thing we can do is we can find where it cuts the y-axis. To find where it cuts the y-axis, you let x equal 0. And to find where it cuts the x-axis, let y equal 0. So those are our first steps. Okay, so to find where it cuts the y-axis, you let x equal 0. Once we do that, we get 2y equals c and y equals c over 2. So it cuts the y-axis where y is c over 2. So it just gives us a slightly better version for q, because we're able to express now p and q in the same way when I find where it cuts the x-axis. I find where it cuts the x-axis by letting y equal 0. When I let y equal 0, I get x equals c over 3. So it cuts the y-axis at c over 3. Sorry, it's 16 in there for some reason. Okay, so now we can create our triangle. So we know our triangle here. We know that if this is the point c over 3, we know the distance from here to this point is c over 3. The same, if this is the point c over 2, the distance from the origin to there is c over 2. To find the area of a triangle, the area is equal to half the base by the height. So we don't need to use our fancy area of a triangle formula from page 18. You know the area is 24. My base is c over 3. My perpendicular height is c over 2. So we'll simplify that out by top, bottom by bottom. So we have 24 equals c squared over 12. So our 12 is dividing. We'll bring it over to multiply. We get c squared equals root 288. So the opposite of squaring is square root. So we find the square root of 288, and we get 12 root 2. Now keep in mind, 12 root 2, if I square it, I'll get 288. But I'll also square it if I get negative 12 root 2. So which answer is right? Well, I say both. So if we take the line 3x plus 2y plus 3x plus 2y equals c, so 3x plus 2y equals c. And we just rearrange it, 3x plus 2y minus c equals 0. Now we can find the slope of this line by doing y equals mx plus c, or a little shortcut. As long as it's in the correct order, slope can be minus a over b, which in this case is minus 3 over 2. It's a negative slope, which means the slope's down from left to right. So if I was to draw an x and y axis, if I have down from left to right, I'm going to create this triangle here, or this triangle here. So I could indeed get my value of c to work in two places. So keep in mind now, where it cuts the, actually sorry, we don't need to do any further. So we can have our two values for c, because it can cut in two places and create the 24 square units if you wish. So I'd say 12 root 2 and minus 12 root 2, because it doesn't mention the whether it has to be the positive sense of the x-axis or not. So both those values will do. Okay, find the equations of two lines parallel to 3x minus 4y plus 1 equals 0 and 2 units away from it. So here in my red, I have my 3x minus 4y plus 1 equals 0. My two back lines are parallel. They're 2 units away from it. So keep in mind that any lines that are parallel have the same slope. Now, remember, if it's in this form, x's, y's, constants equal 0, the slope is minus a over b. So in this case, minus 3 over minus 4, or 3/4. Now, I'm not so much interested in the slope as what I'm interested in is the only things that matter for slope are a's and b's. So if the a's and b's are the only thing that matter for slope, then for all parallel lines, they must have the same a's and b's. So basically, this black line must be 3x minus 4y as well, but I just don't know what that number is. And the same with this one, it must be 3x minus 4y, but I don't know what that number is. So my job here now is to find out the number. If the lines are parallel, they will always be two units from the red line no matter what. So if I find any point on the red line, I know it must be 2 units from either of these. So how would I find a point on the red line? Well, lines go on forever, so you can sub in any value at all you want for x or y, and it will give you a value. So I'm going to find a point on the line 3x minus 4y plus 1. You put any value you wanted for x, I'm going to put in 0 and solve for y. This gives me a value of 1/4. So the coordinate I have on my red line, x is 0, y is a quarter. So, to be clear, the lines I'm looking for are 3x minus 4y plus c. I know that on the red line, I have a point 0 minus 0 a quarter, and I know its distance from the red line is 2 units. So here, let's say we've got the point 0, 1 quarter here. So now I can fill that into my distance from a point to a line. The absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared, and I know that must be 2. My a is 3, my b is minus 4, my c is c, my x1 is 0, and my y1 is a quarter. Once I've subbed in, I'll simplify. 5 will come over to multiply, giving me 10. How do I get rid of my absolute value signs? I can square both sides, or if I wish, I can let it equal to the positive of the right, and also the negative of the right, and solve. This gives me 2 values for c. Now remember, these black lines have the form 3x minus 4y plus c equals 0. Now that I have values for c, I can just fill them in. 11 for the first value, and my second value for c is minus 9. This gives us our 2 parallel lines.